Hello, thank you for joining our demo. We are from ProModel Corporation, and today we're going to talk about how you can use AutoCAD and Inventor with ProModel simulation to help optimize factory layouts. My name is Andy Schild. I'm the sales director over here at ProModel, and I head up our manufacturing logistics team.
And I'm Aaron Nelson, and I am the product manager of ProModel and Process Simulator, and I'm heading up our integration with Autodesk.
All right, today, from an agenda standpoint, we're going to introduce you to ProModel as a company. We're going to talk about where manufacturing simulation can help. And we're going to walk through some demonstrations of the product suite that we provide, as well as the integration we provide with Autodesk. And then at the end, we're going to walk you through a sample build using both of the tools to show you the integration with the Autodesk software. So what does ProModel do? ProModel provides simulation-based decision support tools that allow organizations to predict factory or process performance in a low-risk environment. For over 30 years, we've delivered technology-enabled solutions to help our clients virtually maximize their factory throughput, productivity, and efficiency, minimize lead times and cycle times while right-sizing inventory and buffers throughout the facility, while also looking at labor productivity and labor allocation, while understanding the effects of bottlenecks in the system, where they are, how to alleviate them. In the end, the tools allow organizations to understand the impact of critical business decisions prior to implementation. ProModel is a partner of Autodesk. We provide simulation-based tools for Autodesk clients. We have developed, and we're currently in the process of developing further integration with Autodesk software, with the goal of ultimately creating a seamless integration between AutoCAD and Inventor and factory simulation, ProModel tools. The way our tools help organizations is they allow you to visualize the process dynamically. So there's a couple different ways this is going to look. A process map where you're simulating a value stream or a process flow, and we're simulating in that environment, or it can look like a 2D simulation in AutoCAD, kind of like with the roof cut off and looking down and seeing the material and people and products flow through the factory as they would. The important part is that we're taking into account all aspects of the factory, from the production line to the logistics, to the material flow, to the warehousing. We're taking into account all the business rules and operational parameters that dictate how things move through the system. We'll put schedules and cycle times and downtimes and setup times of machines. We'll put all that information in, we hit play, and we can simulate out over a period of time, say a day, a week, maybe a quarter, to be able to then predict how that system is going to perform under a certain set of circumstances. And once we do that, we can analyze things like throughput. How much did the system make? What was our capacity under those set of circumstances? We can look at the utilization of our people and our material handling equipment, so fork trucks, AGVs. We can look at the utilization of our equipment, so our machine utilization, our uptime, or our OEE. We can look at inventory levels, typically a leading edge indicator of where there might be a bottleneck. Our inventory is going up. Are we stocking out of certain items? And also, what were the lead times based on those circumstances? And once you have a simulation model of a process or a line or a cell or a factory, you then have the ability to use it as a platform to help optimize or maximize the performance of the system. So you can adjust certain dials and parameters to create what-if scenarios to try to maximize things like lead time. We can adjust things like the demand and mix and the schedule to help with line balancing. We can adjust labor quantities and labor allocation. We can adjust equipment capacities. What if we had 3 pieces of one machine versus 2? We batch different, or what if we had different buffer or conveyor options to help deal with buffering a product and work in process? So summarizing where simulation can help, there's lots of reasons to use simulation. Some of the key reasons why you would use simulation: it allows you to experiment and understand the impact of critical decisions in a low-risk environment. It allows you to visualize the actual process flow with animation to identify how the current system really works, not how everyone thinks it works. So it's going to predict based on inputs how the system's going to perform, quantifiable tool versus a subjective tool. It allows you to avoid the error of averages, which always leads to overestimating capacity and throughput. Simulation takes into account variability around cycle time, around downtimes, around setup times. It allows you to capture range of how a process may perform. and it accounts for interdependencies among resources and process steps. When you combine those variability and interdependency, it allows you to understand the impact of as it compounds through a complex process. It allows you to quickly and easily compare alternative scenarios to maximize the performance. So a lot of management capabilities built into the tools to allow you to test alternative courses of action and compare and contrast performance to select the best option moving forward. And once you have a model of a process, created of a process, it allows you to reuse that model over and over. It's a documented version of the process that you can use to test new potential ideas and improvements before deciding to implement. ProModel looks at a lot of organizations in many different capacities. Within the four walls of a manufacturing facilities, we're typically working with organizations to help them optimize layouts. So you may have a layout. We can take that layout and build a simulation model on top of it to scale to help you validate the performance of the layout. What would the throughput be under this layout with this distance between machines, these paths that fork trucks and AGVs move on? It allows you to validate capital expenditures prior to implementing. So obviously you want to maybe look at updating equipment and having faster, more automated equipment, but it's important to understand how that equipment is going to interact with the rest of the process. In effect, if we just shift bottlenecks downstream, or does it truly make our whole overall process more efficient? We do a lot analyzing material handling systems. So the delivery and making material available at the right time is critical for analyzing the performance of a production line or a factory. So we can look at the material delivery practices, we can look at the material delivery equipment and test the assumptions that we have in the factory. So how many fork trucks, what sort of are they going to be on? How many tuggers, what frequency of delivery should they have? How many AGVs to be able to deliver? So a lot of this revolves around being able to predict capacity and analyzing the throughput of a process. And we can take into account complex product mix. So most manufacturers are making many iterations of the same product or a lot of different products. So we can analyze a complex product mix going through the system and understand how that Rubik's Cube of a puzzle affects our overall ability to meet demand or meet throughput rates. As I mentioned, once you have a simulation model built, it's now a platform for you to be able to experiment. So that fits nicely with supporting continuous process improvement initiatives, Lean Six Sigma type initiatives, where you can many different scenarios or alternatives in one spot in a very quick amount of time. A lot of the analysis will be looking at inventory, make sure we have the right stuff at the right time, or we don't have too much, or we don't see trends of inventory moving up and up and up. And looking at the labor, what is the labor necessary to be able to man the equipment and to be able to move parts throughout the system? Not only inside the four walls of a manufacturing facility, but we also work quite a bit in warehousing and distribution. Again, a lot around capacity and throughput and efficiency. So, based on where we slot product, based on the amount of people we have, whether it's automated, our receiving and shipping processes, they all have processes that can be analyzed and improved that affect the overall capacity and efficiency of a facility. So that helps with space analysis and throughput and supporting, again, process improvement initiatives within the warehouse. So when to use simulation? Well, really any manufacturing process that has multiple steps could benefit from simulation strictly because of the interdependent nature of processes. If I change one thing, how does it affect everything else? But really it's about complexity. As we change variability, so the more variation there is on the cycle times or the randomness times or times, the more manual interaction there is, the more material there is that needs to be delivered at a certain amount of times, and the more complex the process. So the more interdependencies there are, the more steps there are on a process, the more options there are and routings based on different attributes of products, the more reason there is to simulate. So with an quick introduction to simulation, next we're going to kind of walk through what the products are here at ProModel. So ProModel has two different simulation tools that integrate with the Autodesk offering. The first tool is called Process Simulator. Process Simulator is a Microsoft Visio plugin. It is a tool that a process map in Visio and automatically create a dynamic simulation model. It is geared towards folks who are not expert model builders, you can drag and drop and easily create a simulation model. It's a rapid model developing tool. ProModel Autodesk Edition is a full-featured simulation software with the Autodesk add-on. It is spatially accurate. It's geared towards more complex processes and operations where the ability to model something to scale is critical. Both of the software packages that we have integration with the Autodesk platform. Currently, both of our products can import scaled AutoCAD drawings into ProModel or our process simulator tool. We can use Autodesk factory assets to actually create the simulation model. So if you have user assets using factory design utilities, you can actually build our sim model with those. And because they have properties associated back with AutoCAD and Inventor, you can sync the simulation models back to AutoCAD or Inventor from ProModel and Process Simulator to help create the layout from the process model. So you can start with a blank sheet, you're designing a new process, and you can set the machines, create the flow, throughput and rate, and then sync to AutoCAD and Inventor to be able to create the layout. And we can also create the beginning of a simulation model inside of AutoCAD and sync to our ProModel tool. So we'll be going through this in some detail, but if you have with assets, we can actually create a simulation model, the beginnings of a simulation model inside of AutoCAD. So why is this important? As I mentioned, we can start with a blank sheet, validate and optimize the process flow, and end with a 2D, and with factory design utility, sync up to a 3D layout. We can use existing layouts to expedite and automate the creation of a simulation model. If you have an existing factory, most likely you have an existing layout. We can leverage that layout to help create a simulation model faster. And with the ProModel tool, we can actually change the layout and automatically update the simulation model. So you may iterate in the simulation model, find you want to move something closer or farther away. You can move it in the AutoCAD drawing, sync back to the ProModel model. All right. With that said, we are going to move into a demonstration of the ProModel and Process Simulator software packages. So we're going to walk through a demonstration of the Process Simulator software package. This is the plugin to Microsoft Visio. As you can see here, we're inside the Visio environment where we've created a process map. This map is using stencils and icons, or actually using system assets that are inside of ProModel from Auto, your user assets or system assets. But we've created a process here of a shovel manufacturing facility. If you look up on the top line here, you'll see that we have some steel that's coming into the process that's going to go through some pressing, grinding. On the bottom, we have some pipe that's going to come through its sawing and grinding and bending press operations. They're going to come together on a bench, grinding operations. They're going to go through thread cutting. They're going to go into a buffer where they're then going to be able to fed into the assembly line. So once we build out this as it's already built, which we're going to walk through showing you how to build a simulation model in a little bit, but this is really to show you is utilized and what it can show. So once I build the simulation model, I now have a dynamic simulation model that's showing this process in action. I'm capturing some on-screen metrics such as how much work is in the in buffers and out buffers, and I'm seeing product as it flows through the system. You're going to see these workers moving back and forth, doing the drilling and grinding operations. You're going to see work queuing up as it goes into the assembly operations. So we have assemblers that are doing the work from pre-assembling to the wrench. And we also have some purchase components that are actually feeding into some of the assembly operations. They're going to pack and ship over here, and they're going to go out the door. This particular operation was undergoing a change where they're seeing a large increase in demand, and they're going to have to increase production rates by 30%. So in this particular instance, this customer wanted to establish a baseline and be able to simulate and understand where some constraints and bottlenecks are to hone in on some potential improvements that could help them get to the 30% growth that they're going to need to hit. So what you're seeing is the ability to be able to speed up the simulation and to run to completion very quickly. You can turn the animation off. We can run through 48 hours of production very, very quickly. Once we complete the simulation, we now go to a dashboard called the ProModel Output Viewer that can display the results where we can analyze what happened in the system. So we model the baseline. Now we get reporting to show us what happened. my my dashboard here, I have a couple things that we're looking at. One is how many exits did we have out of the system? So from the end of the production line, we had 267 shovels that exited the system. And then I can dive into more diagnostic reports to see what happened. So in this particular instance, I'm looking at my operations here, and I see this pre-assembling operation where this operation was in operation 22%, idle 11%, and waiting on a person to come do the work for about 67% of the time. So there's a potential issue there where there was not enough resources or labor to come do the work as it was waiting a long time. And if I look down at my thread cutting machine, the thread cutting machine, it has high utilization. So there's a potential that the thread cutting machine is a potential bottleneck and opportunity to potentially capacity there. And if I go and look at my people, I can look at the assembly worker that was tasked with some of the pre-assembling steps, and I can see those set of workers were about 90% utilized. So there was some overutilization there that may be preventing us from getting enough through the process. So what I can do now is I can go take that analysis that I did, and I can create one of those in my process to help improve it and test the system to see what will get me up to the 30% increase in production that I need to hit. So inside ProModel Scenario Manager, I have the capability to create and modify scenarios very easily. So I have my parameters that I want to test. So in this instance, we're looking at the amount of assembly workers or the thread cutting machine. So that's our baseline where we had 2 workers. And we looked at what if I added a second thread cutting machine? So now I have 2 workers, 2 machines. And then I look at adding a third worker. And so what if I had 3 assembly workers? And what if I did both? So what I can do is actually now run all those scenarios in succession. And then at the end of this run, we'll be able to show the impact that all those scenarios made, compare and contrast, so we can make the best decision possible. So I'm going to turn off the animation of this. You can see that now we're on our second scenario. Now we're on our third worker scenario. And now we're on our add both scenario. And again, now I launch my output view, and I can go in and analyze what happened in my process. So once we've identified potential bottlenecks and identified potential improvements and run through different scenarios, we now can launch into the output viewer within ProModel, our dashboard, to then view how those different scenarios performed against one another. So if you remember our key metrics, we're looking back on essentially throughput and trying to gain a 30% improvement in throughput. So we have our scenarios on the left that we ran. So we ran a second thread cutting machine, a third worker, and doing both. So if I add a thread cutting machine, it actually doesn't yield me anymore. I go from 278 pieces all the way up to 278 pieces. So if I look through some of the analysis here, what actually happens is as I add that second thread cutting machine, what it actually does is actually puts more in the buffer in between the thread cutting machine and the assembly area. So I went from having 7 units minimum, and then an average of 22 to having 77 on average sitting in the buffer. So I have a lot more work that's just now sitting in downstream. So if we just spend money on a thread cutting machine, it's not going to get us any more. And if I look at adding maybe a third worker, well, that improves somewhat. I go from 278 units to 310. But what actually ends up happening is the opposite. There's not enough material or work sitting in the buffer in front of the assembly coming from thread cutting. So I go to 22 where I actually never had really anything on average sitting there. So that means we're starving the assembly line. And then if I look at adding both, where I add a thread cutting machine and add that worker, you can see that I have a great jump and achieve my 30% improvement in throughput and have less WIP sitting in the buffer, but enough where I don't starve it. So if I'm doing the analysis, I'm trying to determine what are the improvements that I need to make to improve this factory from 270 units up to an increase in 30%. What I need to do is add a thread cutting machine and add a worker. So now I can use the simulation model and results to go back and justify adding that capital piece of equipment and adding a new hire. So that's a quick overview of the process simulator tool, which is a good introduction to how simulation tools are utilized to answer business questions. All right, now we're going to move over to a demonstration of the ProModel software package. So you saw the process simulator package, which is the Microsoft Visio plugin, a way to very easily and rapidly create a simulation model inside of a kind of process map view in Visio. ProModel is a much more detailed, spatially accurate version of a simulation model. Here you can see we're using a 2D AutoCAD layout of a facility. And what you're seeing here is a tier 1 automotive supplier where we, on the right here, have an assembly line that's assembling product. We have sub-assembly lines that are assembling product down here and feeding into the main assembly line. You can see on these blue lines are fork trucks and AGVs moving throughout the process, and on the far left is a warehouse. What this client was looking to do was to be able to validate that the assembly line could meet certain rates. So we helped them, they use the simulation to look at the assembly line and make sure they have enough buffer and enough pallets in the assembly line to meet rate based on their complex product mix. And then to be able to look at the sub-assembly lines in the same manner to make sure they can meet certain rates. And then look at the delivery mechanisms from the sub-assembly lines to the main assembly to make sure they had the right parts at the right time. So that's looking at delivery frequencies, the numbers of products they need in the queue, and then in turn, on the line side, storage of all these assembly lines that we have here, we're delivering purchased components that are stored in the warehouse and delivering them down to different spots on the assembly line. So within the assembly lines, we need to keep a certain number of sub-assemblies and components to assemble. If we don't have the right stuff at the right time, then we stop the line. So this model looked quite a bit at the material delivery systems or the in-plant logistics to make sure that there's enough product in the assembly line and the sub-assembly lines at the right time. And then on the very far end, we can actually look at the warehouse and help size the warehouse appropriately. We're trying to utilize the smallest footprint possible. So we want to store as little as possible, but make sure we have enough product where we don't run out, so we don't have a stock out on the line. So this model is also used to help size and design the warehouse. And again, all the material delivery systems like fork trucks that are delivering from the warehouse to the line side and to the sub-assemblies. So this is simply a different view of what our tools look like. Again, the ProModel tool here that you're seeing here is a much more powerful, spatially accurate tool for helping design and validate factories, while the process simulator tool is a rapid modeling tool that can have you model a process very quickly. So with that said, after this short introduction here, we're going to pass it over to Aaron, where Aaron is now going to walk through some sample builds and how to build using the simulation tools and how the integration with the Autodesk tools work.
Hi, yeah. So this is Aaron, and I'm going to walk you through the process simulator sample building using the process simulator Autodesk edition. So in process simulator, we have a workflow and integration inside of Visio that allows you to take a new process design or layout, or change a current process design or layout. Inside of Process Simulator, if the CAD drawing exists, we can import that into Process Simulator. We lay factory assets down into our model. We call those assets or locations. And then we can define different resources or constraints, basically operators or other MHE. We define product mixes. Those are what we call entities. Define process flow routings. And once we have all that set up, we can then define different parameters for experimenting, for different experimentations. We can define different KPIs, key performance metrics and reporting. And we can set up and run scenarios using our scenario runner to look at different processes or layout options. We can analyze our reports like what Andy showed to identify the best process or layout options. Once we've done all of that, we can then sync back to AutoCAD or Inventor. So let me go ahead and walk you through a quick process of how that's done. So I am starting with a blank drawing. I'm going to start by adding an entity. So I'm going to have what I'm going to call a work unit. And I want that to go to a couple of different CNC machines. So I'm going to come over here into the factory asset browser. So I'm going to come over here to my factory asset browser, and I'm going to do a search. I can either drill down through the asset browser and I can find the assets that I want, or I can come up here to the top and just do a search for a CNC machine. So I'm going to grab the CNC lathe, and I want to have two of these guys. So I'm just going to copy this one, place it down here, and then I want a mill for those to feed into. So I'm going to grab this vertical milling machine, place it right here. And lastly, for my locations, I want to have an inspection station. I'm going to do a search for an inspect. I'm going to grab this visual inspection station. So now I have a work unit that I'm going to have flow through these locations, these factory assets. So I simply can click and just drag using my Visio connectors to these locations, these assets. And if you notice, each one of these has their own properties. When we drag a routing arrow from an entity to an activity or these assets, these arrows are what we consider as the arrival properties. So we can see that there's some default properties already added. We can change those though. We can have periodic arrivals. We could have a scheduled continuous order or a pattern. When we are looking at the different lathes, each one has its own properties. And by default, we have this triangular distribution for processing time. I could right click and go into a distribution builder, pick a different distribution, create my own, and give it its unique processing capabilities. I'm going to then just continue the process and route from my lathes to my vertical milling machine. I will then route to the visual inspect, and then I'm going to have this route out to exit. If you notice, it says exit when it goes to nothing. I'm going to select that, and I want to say that I've only got 90% of my work units actually exit the system, and I want to have 10% go back to be milled again. So if you can see, I have this kind of a rework loop of 10%. That's going to be key in just a second. So in addition to these locations, I'm also going to add a worker, a couple of workers. I'm going to add a man that does my inspection, and I'll put him right there. And I'm also going to add, and we'll make him a little bit smaller. And I'm also going to add a forklift. I'm going to use, let's put the forklift up here. And I'm going to use the forklift to transport from the vertical milling to the visual inspect. The man is going to be used just at the visual inspect. So to do that, I'm just going to select the resource right here. Make him a resource. And I will then pick the man to be used at the visual inspect location. My forklift, I'll set that to be a resource, and I will have him be used when I go from vertical milling and also from Visual Inspect back to vertical milling. So I'm going to pick my resource. There's a forklift. And then to give it a little bit more realistic movement, I'm going to add a path network for my forklift. Oops. Let's zoom in right here so I can click on this. So I can, without making too many changes, I can go ahead and simulate and see how this system functions. I can see that my forklift is used to transport back and forth. It will move from the milling station to the inspection station. And my man that's doing the visual inspect, he will turn green whenever he's being used. So I have a static resource that doesn't move, and then I have a forklift that moves back and forth. So I'm going to go ahead and speed this up and allow us to see what this system looks like in a 40-hour period of time. So real quickly, I'm able to see that I get 355 exits out the door. I showed that my work unit, for the most part, is blocked because of just the way that I built it. My man is being overutilized considerably. But all in all, this is the statistics for this system. So I added that rework loop because I wanted to show you a really quick and easy way that we can run experiments. We can just simply open up the scenario manager and we can add parameters to experiment with. And something super easy that we could do is we could check the percentage routes for the visual inspect station. So right now I've got a percentage route to exit and route back to the milling machine. So I've added those, and you can now see those exist here in parameters I can do experiments with. I could then say 15 fail and do an experiment with, well, what if I had 15% of my parts fail and only 85 exit the system? I could also do one for 5 fail. And have kind of the opposite and be able to analyze that. So let's see, 95 and 5. And quickly, just with making those changes, I can run the scenarios. I can either grab the slider and move over and speed things up really fast, or I can disable the animation and quickly say yes and analyze inside of Output Viewer what that one simple change did. So I'll go ahead and I'll select my 3 scenarios over here, like Andy showed us earlier. And I can see, here's my baseline, which just running one replication, I was able to get 355 parts out the door. If I only had 5% of my parts fail, maybe the mill, different types of mills that we purchased may have a different fail rate of finished product. So if I had 5%, I got 375 out the door. 15% is 324. So really quickly, I'm able to build a model that I can run an experiment with. All right, so once I've run my experiment and I've been able to get the information that I need out of it from my different KPIs, I can then simply come up back into the Visio process simulator ribbon. I can select in the Autodesk section, I can choose to open in AutoCAD, or I can open inside of Inventor. So I'm going to go ahead and open this in Inventor. But first, before you open in Inventor, you have to save your model. So once I've saved my model, I can then come up here to the workflows, and I can open inside AutoCAD or Inventor. I'm going to open this inside Inventor. Inventor and AutoCAD have to be open if you're going to import into them. So what this is doing is it's grabbing the assets from the factory asset cloud, and it's going to bring them into this drawing inside of Inventor or AutoCAD, and we're able to quickly see all the assets that we use. We can then move those wherever we like inside of the drawing, and we can start building our factory around those. Or we could have named our drawing in our model inside of Process Simulator the same as an existing AutoCAD or Inventor file, and be able to import these assets back into that drawing. So this is just a quick, simple one. I have a block for my entity because that really so it imports back into AutoCAD or Inventor those assets with all the properties that they have from the FDU. So I can then manipulate those the way that I need to. I can place them exactly where I need them in my model and be able to go back into Process Simulator. I can go back into Process Simulator and be able to add to this model, remove things, make different changes, and then import those assets as I need to back into my model. It will keep the placement inside of AutoCAD wherever you put them, or inside of Inventor wherever you put them. All right, so I want to move on to building a ProModel model. We have a little bit different workflow with ProModel. Step one, you start inside of AutoCAD. We open AutoCAD layouts that contain factory assets. With that CAD drawing, we can go in and we can mark locations within the drawing. You can mark the assets so that it represents a location inside of ProModel. We define a process flow all within AutoCAD, and that will be used for our product or parts to route from location to location inside of ProModel. We set the AutoCAD drawings views on or off, whichever ones we want to be visible inside of our ProModel model, and then you simply open the CAD drawing within ProModel. The base ProModel model will be created and opened, and the layout's going to be automatically imported and scaled exactly how you had it turned on inside of AutoCAD, and the locations will be automatically defined for those factory assets that we selected. Entities that you added will be in there, and there will be process flows for them. The next thing that you can do, step 2, is we can define additional locations, resources like my forklift and process simulator. We can add different constraints, extra buffers, material transporting. We can define more parts that need to be in the system. We can add more complexity to the to your routes, define different arrival schedules. We can set up and run scenarios like we did in the example that I showed you with the process simulator. We can then analyze the reports, identify the best process or the layout options, and we can go back into AutoCAD and we can make any changes to the layout that we need there. We could add or subtract a factory asset and then resync that back into ProModel and be able to run our experiments with those changes. So I'm going to go ahead and show you how that is done. So here in AutoCAD, we have added a ribbon inside of AutoCAD when you have the ProModel Autodesk Edition. It's a really simple ribbon. We have a button to add flows. We open up the simulation browser and simulation properties, which I already have open over here on the right-hand side. And this is where you're going to be doing the model building inside of AutoCAD. We have the 3 sections: locations, entities, and flows. Locations, if we want to mark an asset that's inside of our drawing, we select Add. And down in the command line it says pick the locations. So I could pick these locations and simply hit enter, and it will mark those and add them as locations to be used in ProModel. Entities, we can hit add, and that will automatically, since it doesn't exist in the layout, it'll automatically just give us an entity name. But really one of the features that I like the most is being able to create a product flow. A product flow is basically how we did it in Process Simulator. We have a flow from location to location and what's moving from location to location. So you can have multiple flows in the ProModel Autodesk Edition. And each of those flows could have multiple entities if you like as well. So I'm going to select Add to add a flow. And down at the bottom in the command line, it says enter a flow name. So I'm just going to call this Flow 1. And, or flow. I'm going to call this flow. And then I'm going to pick an entity. And I want this to be the spade, like in the model that Andy was showing you. So I'm going to hit spade, hit enter, and then I will start selecting assets that I want to be in my simulation and be part of this flow. When I select it, it will automatically start to add the location. If it didn't exist, it will add it. It's a really cool feature, along with properties that belong to this location, how long our entities will process at that location. I can then select the next asset, and it will draw a routing line to that next destination. And as you can see over here in the simulation properties, I have that routing line is selected in the browser, and I have time and as well as the source and destination and how it routes to that destination. Right now I have it just saying first available. I could use a percentage. I could change it if I want. I can then simply just continue to click on the different assets that I want to be part of my simulation. Once I'm done down in the command line, I can select the exit command, and it will exit the system. So quickly, I've gone through, just like I did in Process Simulator, but maybe a little faster. I've added a process flow inside of my CAD drawing. I could go in and change these distributions if I wanted. I could type them in by hand, or I could use our distribution builder by right-clicking, like I just did right here. I just said that the surface grinder, instead of the triangular distribution that you saw, now it's a normal distribution. Once I have it looking the way that I want, I simply can open this up inside of ProModel. So it will launch ProModel. And it provides me a quick and simple model that I could start to simulate. I have my locations. I have entities. I have an arrival of my spade because I created that process flow. I have different processing records. So this is how we translate everything that you just did inside of AutoCAD. And I can quickly run this simulation and see my process to scale run within ProModel. I can disable the animation and view my statistics really quickly. Now, granted, I just have default values in here. We can come in and we can add additional coding. We can add our business rules that reflect the different decisions that need to be made at each location and as we route from location to location. We can add resources. We could add conveyors, which is something that we're currently working on right now. We'll be implementing here within the next month, conveyor systems inside of AutoCAD so that you can use conveyors within your CAD drawing and be able to bring those in seamlessly and be able to build a simulation using those. So what if I wanted to change my my layout? Well, AutoCAD is amazing for building layouts. Right, so I can quickly just copy a asset and then paste it back in wherever I wanted it. I could even move an existing asset. I could come in and delete this exit and hit add a route and choose where I want it to route to, and then have this one be the one that routes to exit. But reopen it back in ProModel. And I now have all my changes that I did in ProModel reflected here inside of my model. It's a really powerful simulation tool that you're able to now utilize what you've already done inside of AutoCAD to be able to quickly and rapidly be able to build a simulation and run experiments off of this.
Thanks, Aaron. Great overview of the capability and the integration. So just to wrap up and summarize, ProModel provides a powerful suite of simulation tools to model any type of manufacturing environment, from modeling a simple cell to modeling an entire line, to modeling a plant, to modeling an entire supply chain network. The power is there to model those type of applications. The simulation then provides you a platform for maximizing the performance of your factory, to be able to optimize and test and experiment, and to be able to simulate before you go and do on the factory floor. In conjunction with Autodesk, now the integration provides a seamless integration to create or leverage existing layouts and help optimize your process flow. That wraps up our session for today. We thank you for joining us for our demonstration. As I mentioned, this is Andy Schild from ProModel and Aaron Nelson from ProModel. And our contact information is here. If you have any questions, please feel free to reach out. For any technical questions, you can reach out to Aaron. For any sales related or licensing inquiries, you can reach out to myself. Actually, you can reach out to either of us and we'll be able to help you out and point you in the right direction. So hopefully you found this talk valuable and are interested in learning more. And if you are, please feel free to reach out to us. Thank you.